Okay, so we're first going to just look at this and we're going to say, okay, if I um, organize this a little and I put the constant on one side and the variables on the other, I would have a negative x squared plus x plus y is equal to negative 6. And then I would have x plus y is equal to negative 2. Now, this isn't the typical problem because this is actually a quadratic and a linear function trying to hit. So basically you have something that's either coming like this and then another line. So we have the possibility of having 2 points. We haven't done a lot of these yet, but I just wanted you to look at one first. So we're going to have this, we're going to multiply this by a negative 1. And so you have negative x squared plus x plus y is equal to negative 6. And this is negative x minus y is equal to 2. So these will go away. And you'll have the opposite of x squared is equal to negative 4. So when is x squared equal to 4? Well, in Algebra 1 we knew we take the square root of both sides plus or minus. So this is when x could have been a positive 2 or x could be a negative 2. So what we're going to do is we're going to end up with 2 points. So the one is going to have a 2 for x and then the other one is going to have a negative 2. But we have to find out what the answers are. So we're going to put it into B, and we're going to have 2 plus y plus 2 is equal to 0. So we're going to have y plus 4 is equal to 0. So y is equal to negative 4. So when x is 2, y is equal to negative 4. We'll do the same thing except for with negative 2. So if I put a negative 2 in here, instead of having a 2 here, I put a negative 2 here, then this is now 0. We should have probably written it over, but I'm just going to erase it. So now this is 0, so this is just y is equal to 0. So those are our 2 points. So in this case, this wasn't independent, dependent, or inconsistent because these were not both linear. Okay. All right. So let's look at number 9. Number 9, the variables are not lined up. So let's subtract 6x from both sides and we'll get negative 6x plus 3y is equal to negative 12. We will add 10x to both sides there, and so we'll have 10x minus 5y is equal to negative 20. There's a lot of ways that you can do this. You can make these both opposites or you can make these both opposites, but you can look at this and see this has a 6, a 3, and a 12. They're all divisible by 3. I can divide this whole thing by 3 and maybe it'll play nice with us. So that is negative 2x plus y is equal to negative 4. These are all divisible by 5. So I could divide this whole thing by 5 and this will give me 2x minus y is equal to a negative 4. Okay? So what happened was when we did that, they all played nice except for everyone went away, all the variables zeroed out, and then we got negative 8. This, when the variables zero out and you have a false statement, the answer will be no solution. So here's algebraically what it looks like when things are inconsistent. Okay. These are both solved for y, so you can just put them equal to each other because they're both equal to y. However, we have a quadratic again. You can see the quadratic. Now, some of you need reminders about quadratic, others don't. So right now you have x squared plus 2x is equal to 0. Well, when is this going to happen? Well, it's going to happen when we factor and then set each factor equal to 0. This is stuff that you learned in Algebra 1, but if you don't remember it, we will be reviewing. So x is 0 and x is -2. So again, we have 2 points because we have a quadratic and a line. The first point will have a 0. The second point will have a -2. If I put a 0 in for x, y would equal 3 times 0 minus 2. So our y would be equal to -2. If I put a -2 in for x, we'll have -6 plus a -2, and that will give us a -8. So our 2 points will be 0, -2, and -2, -8. So the reason why we have 2 is because we're now still talking about a quadratic and a line. So it has the possibility of hitting twice. Okay, so to graph the solution, when you have this boundary, this is a linear boundary, so you're going to start at -3, and you're going to use a slope of 1 to go up 1 over 1, up 1 over 1, up 1 over 1. And because there's a line under there, we're going to include that boundary. Okay. Now we're going to put a point in. I'm going to put 0, 0 in. Is 0 greater than or equal to 0 minus 3? Is 0 greater than or equal to -3? And the answer is yes. So since this is true, I'm shading this way, because I'm only going to shade my true points. This is also a line, but we can divide everything by 2 to get it into slope-intercept form. So y equals 1/2 x plus 3. So this one starts at 3, and it goes up 1 over 2, up 1 over 2. So it's going to go up 1 over 2, and we're going to probably take a little bit of time, but we will hit, because they are not, you see how this guy has a slope of 1 and this has a slope of 1/2? So we are going to hit, we just won't hit maybe in our picture, so we're going to have to extend it. Up 1 over 2, so this line's going to be going like this. Okay, so I probably should have used a different scale for this one, so maybe next time that I would do this, if I knew it was going to be out here, I would probably go by 2s or something like that. But so right now we're going to put 0, 0 into our original function, which is 0, 0 plus 6. So 6 is definitely bigger, so it'll be going down. So you can see that our feasible region is going to be right here, and that'll do it for right now.